November 2022, Elegoo released a budget 3D printer, Neptune 3 Pro, with MSRP at $300. It launched at 10th December, with the pre-sale price at $230. It has been popular since then. I have checked their official website and Amazon every single day since January. They are out of stock, and mid-February, it back to stock at US with a $10 new customer coupon. It brings down the price to $220. It is a very similar price with the Ender 3 V2 and other budget 3D printer at this point. Is it another budget 3D printer out there with similar formula? Or is it something different? We're gonna find out soon. Like most budget 3D printer out there, Neptune 3 Pro is also built on i3 structure and T-slot wheel motion system. Unlike other budget one, behind this nice stylish gantry, Neptune 3 Pro comes with two Z-axes. The threaded rod is also reinforced by two bearings on top. A bell was used to synchronize the motion on both sides. The base of the printer is also covered by injection molding plastic to give a better look and prevent dust. I was first thought the color of extrusion aluminum is only painted on the outer layer like the traditional black one, but it is actually fabricated with this metallic dark blue aluminum raw material. It is hard to describe the exactly color. Let's say sky blue. You think color like this. Let's say Tiffany blue. You think color like this one. To me, the blue on Neptune 3 Pro is like deep ocean blue, like this, but metallic. Neptune 3 Pro comes with 2-gear direct dry extruder. The extruder layout is very similar to spider extruder from Creality. The stainless steel has 3:1 gear ratio to provide strong grip for filling filament. Heatsink of this printer looks shorter and wider compared to V6 style heatsink. The heatsink is cooled by 40-20 blower to prevent heat creep caused clogging. Also notice that there are two part cooling fans. With this formula of this extruder setup, it should be provide good airflow to high-speed printing. The heat break comes with this printer is made of titanium alloy, but it is not full metal one, so it could only reach 260 Celsius max nozzle temperature. A PEI build plate is also come with this printer. A square printer bed with size of 235mm x 235mm and 280mm height. The max temperature of this printer bed is 100 Celsius degree. Instead of spring and adjustable knot under the printer bed, Neptune 3 Pro comes with very stiffer rubber bed spacer. 36-point auto bed leveling feature was powered by this little inductive sensor. Neptune 3 sets bottom right corner as a datum point instead of the most common one on the bottom left corner. Also notice that there is no limit switch on the Z-axis. The sensor is also used to home in the Z-axis. Underneath of this printer is Robin Nano version 2.2 motherboard. Chip model is STM32F401, which is exactly same with Ender 3S1. And there are 4 silent step motor driver underneath. We can see the dual Z-axis step motor is connected in one motor driver. There is also an empty E slot and empty step motor driver slot. Maybe we could add another extruder on it. This 4.3-inch capacitive touchscreen on the side of the printer is attached on the main board by an old phone style cable connector. You can easily take it off and hold it on hand. Why would you like to take it off? The UI of this little touchscreen is not perfect, but it is generally very easy to use and very intuitive. It is also have many features that allow you to play around. This printer is quiet during idle and printing. Notice that when the nozzle temperature below 50, the printer will automatically shut down the heatsink cooling fan, but the mainboard fan underneath still sounds a bit loud. A quick comparison on noise level of the printer that was tested. The electricity consumption on idle, heating, and printing PLA is shown. It is interesting that Neptune 3 Pro bed heating logic is a little different with other printer during the printing. Notice that when bed is cooling down, it will boost full power up and heating it, and when it reaches setting temperature, it will drop back down the electricity drop again. Other printers just maintain a small amount of current to keep the temperature. Which one is better? I can't tell you an answer without running a test on it. Electricity consumption compared to other printers. Let's check out the temperature on step motors. Notice that the step motor on y-axis is the one that has always been the hottest. Autoprint with a USB cable come with the printer is checked. Plug in and play. Pretty simple. But make sure you don't insert an SD card while you're printing through the autoprint. It will cause a printing fail. Neptune 3 Pro also come with belt tensioner on both X and Y axis. Filament sensor is attached underneath the filament holder. Also, under the gantry there is LED light hidden there. It will help you to see better when you need to go to the bathroom at night. Thank you, Elegoo. It sounds like a fully load of hardware and features on paper. Is it really work nicely as it's supposed to be? We'll find out soon. Neptune 3 Pro comes with a lot of pre-assembled parts. The entire assembly process should be less than 15 minutes. Alright, let's get started to put it together. First, let's mirror the gantry to the base. Use M5 x 45mm bolt. Notice that the spring-loaded washer should be installed with the bolt. There are pre-cut slots on both sides of the base to help you find the correct location. Let's move the printer to the edge of the table. Bolt holes are covered by the ribbon cable. Tight the bolts where it's just enough to hold in gantry, but not all the way yet. Place the square on the base to verify the gantry is perfect, 90 degrees to the base. We can continue to tie the bolts more. Rotate other side, repeat the same procedures. Lastly, let's lock all the bolts all the way in. Next, let's use M4 bolts to lock the screen holder on place. It is easier to work on the edge of the table again. Now we can attach a filament holder on top of the gantry. Don't forget to put the filament rundown sensor on as well. We can start connecting all the wires. Let's first do the filament rundown sensor, X-axis motor and limit switch cable. Notice that there are 3 pins and 4 pins connectors. Next, move the extruder down by pulling the synchronized belt behind the top of the gantry. First, attach a ribbon cable to the metal carrier. Make sure it's locked. Continue working downward. There are 2 pins and 3 pins connector for LED light and filament rundown sensor. Also, connect the Z-axis motor. Repeat on the other side. Important step. Switch your power according to your region. As I am in the US, it should be 115 volts. Interesting fun, there is a 2.5 amp DC power output here. Maybe you can power something device on, use this outlet. Don't forget to attach a ribbon cable on the axis carrier. Alright, let's do some simple calibration. As mentioned earlier, there's no nut under the printer bed. We just need to adjust the eccentric nut to find the proper tension for all wheels. The wheels should not be able to move freely by finger push. It should not be too tight at the same time. Adjust the belt tensioner and make sure the printer bed is not shaking. The motion should be linear and smooth without any empty steps. Repeat similar procedures on the extruder carrier. Adjust the belt tension on x-axis. The eccentric nut is located on the bottom. Also notice that due to the weight, the extruder assemble is carried by 4 wheels instead of 3 wheels. Lastly, adjust the eccentric nut on the z-axis on the both sides. Some degrees of up and down movement are allowed. The nut on the backlash coupler no need to be tightened fully. After simple calibration done, we can start doing bed leveling. Select level on the touch screen. It homes all position and start heating the printer bed and the nozzle. We can see the bed mesh compensate as shown on the screen. Select level on the touch screen. We don't need to do anything during this process. It will take around 7 minutes to complete. You can go grab some drink for yourself while waiting. After auto bed leveling done, it will tell you the correct first layer. Nice information for beginners. Well done, Elegoo. Now we can take pieces of letter paper, or use this instruction paper come with the printer. Simply place a paper on the nozzle and pulling it back and forth. Adjust the Z offset value on the screen at the same time as shown. It is easy to use the 0.1mm to reduce the number first. When you feel strong friction from nozzle, use 0.01mm to increase the number. Until you feel slightly grip force from the nozzle, and you are ready to go. Now we can go ahead and use a slicer to prepare some printing file. Latest Qla already have preset configuration for Neptune 3 Pro. But I'm more like a prusa slicer person. Configuration is not available on prusa slicer at this point. We can use a Neptune 3 Pro file and make modify on that. Go to the machine setting, extruder setting, reduce the retraction setting. Since Neptune 3 Pro is direct dry extruder, let's leave it at 2. We'll find out if we need to change any numbers or any settings after test print. I don't think bed leveling before every single print is necessary, so I just delete the G29 on the starting G code. Also increase the prime nozzle line flow from 10 to 15 and 20. Alright, let's get started printing. We are going to test this machine with different models, filament, and speed to figure out its performance right out of the box with the really basic calibration. Test PLA filament were sitting on the floor in my room in open air for over 6 months, but the humidity was around 40% to 45% all the time. First, we are going to do some general tests with a PLA. Let's get started with a calibration cube. As the calibration cube was used to test the general layer finish and the accuracy of the overall dimensions. I have one very bright LED light sitting above the printer part, and I'll rotate the printer part around in different angles. Just make sure you can see the layer defects during the video. As you can see, the calibration cube layer finish isn't perfect. It could be due to the filament was sitting in the room for too long and poor quality of the filament. But the overall dimensions are very accurate. On the test frame 2, we are going to test the filament runout sensor and bring resume feature. As you can see on the finished calibration cube, there is a 2-layer line separated very obviously. Also notice that the printing speed is 100 millimeters per second. Now let's continue print with same file. Notice that this 100 millimeters per second printing speed reduced 9 minutes of printing time for this little calibration cube. And this time, the layer defects little more obvious compared to first test print. Notice that there is a gap between outer and inner parameter with the infill. Next, we are going to use a little bit of remaining white PLA to test print the benchy. As you can see, the benchy layer finish isn't perfect, and there is a little small gaps and Z layer seams you can see. Other than that, all the little details and overhang are all finished really nice. I increased the printing speed to 100 millimeters per second. Also, instead of using micro SD card, I used a USB cable connected to a Raspberry Pi, so I could send a printing file wirelessly, and at the same time, I could record in some nice footage like this one. As you can see, the printing quality didn't really turn out well. The layer finish overall are smooth, but you can see a lot of small bumps on the side of the benchy. It is due to the feature of auto lasp, which it does is every single layer shift, it will move the nozzle to the center of the printer bed and take a snapshot and moving to the position to continue printing. Next, I further increased speed to 150 millimeters per second. As we can see, the finished benchy looks okay. The layer finishes looks alright, but we can see part cooling issues on the right side overhand area. At the same time, notice the Z-Sync bobs still there since I don't change the Z-Sync settings from the sizer. As I mentioned earlier, this printer comes with a 2-part cooling fan, and I really wonder how this 2 cooling fan does compared to the other one with a single cooling fan. As we can see, the overhang test turned out pretty nice. It tells that this printer is able to handle overhang around 50 to 60 degrees with no issues. But let's do a quick comparison with the other printers. These 2 overhang tests was done by Sovol SV06, done only stock part cooling fan. The other one was done on 5015 upgrade one. As we can see, the one from Neptune 3 Pro is very similar to the upgrade one, and significantly better than the stock one on the Sovol SV06. I want to see the full potential of this part cooling fan, so I run an overhang stress test. This overhang spring tests are generally hard to print. It requires a strong airflow from both sides and merge at a small area under the nozzle. The dual-part cooling fan works really nice for most applications, but not so well on crazy overhang like this. I want to run this test print to further test it. This model is generally hard to print. The gear surfaces are close to each other. Generally, direct dry extruder has an advantage in nature to doing this test, but let's see how it turned out. I was really surprised by the printing result. After simple push on both sides, this bearing runs very smoothly without any issues. There was adjustment and subtle change on the slicer setting throughout test print. Now I want to confirm that 100mm/s speed we use for general non-complex shape model for this printer. This model comes out faultlessly. The print quality is amazing. It is hard to find a layer line, and overall finish are really smooth. This model also concedes many big overhang, but the dual part cooling fan are doing well with this kind of big parameter overhangs. Next, let's move to the PETG filament. This PETG filament was in the room for over 3 months since my first review video. Also, I forgot to change the seam to align. For this particular model, the nearest seam will have this kind of ugly seam showing. The thread match really nice. I can fully lock it on with no issues. Next, let's print with this clear PETG. I also changed the Z seam to align. As you can see, this shell turned out really nice. There's only a little bit of stringing underneath of this print. Other than that, the finish are really smooth and overall looks pretty nice. I want to run an endurance test with a PETG filament for this machine. Unfortunately, the auto print video recording was failed during this test print. This test print was set 70mm/s print speed, and it almost takes 25 hours to print. This print looks nice overall, but there's still some layer defects on the surface, as you can see. Now, let's put a light bulb inside this crystal. Alright, we are going to continue test TPU filament with this printer. This little table spacer turned out really nice. There is no stringing between different parts, and the finish are nice too. So sometimes the glue stick on the printer could be very handy if you print a lot on ABS and polycarbonate or carbon fiber. Alright, since we mentioned about ABS, so let's run a test print in ABS too as well. Let me first move the printer to a bathroom. Filament holder print turned out really nice. There's only a little bit of blobs and empty holes on the surface. Other than that, the print overall turned out very smooth and very nice. Final thought of Elegoo Neptune 3 Pro. We have gone through the hardware feature and running different test print of this printer. I have to say first, The price of this printer versus its hardware feature and printing quality are amazing. It could be the best 3D printer under $300. The whole test process from assemble, calibration, and test print are painless. It is very easy to assemble like many other pre-assembled printers. The dual-gear direct dry extruder is very capable with many different filaments. The print quality is mostly good. The stress test with tons of retraction with the TPU filament still able to print without any clog. There are also many different attention to detail on this printer. When you remove the SD card from the printer bed will automatically move back and make your life easier. The stepper driver is also coated with black color to give a more cohesion look with other components. The filament runout sensor and extruder are very easy to insert filament. It seems like Elegoo put some sort of electrical component in the mainboard to remove the electricity produced when you're moving the step motor around. I don't see the screen light up during the step motor moving. Instead, I hear very little beep sound from the base of the printer, where the mainboard was located at. The USB cable come with this printer is really handy when you work on the auto print. It does not power the printer on when you connect a Raspberry Pi. The auto bed leveling feature also work nicely to compensate the imperfections on the printer bed. I did my first bed leveling and it go nicely all the test print without readjusting it. The PEI sheet also nice to work. All the filament are stick nicely on it. From my previous experience, the printing filament like polycarbonate and ABS, you'll normally need to move the nozzle a bit closer to the printer bed. But during the test, I will give a little bit more of the negative Z offset. But it ended up shows the filament was too squishy on the printer bed, so I adjusted the Z offset back to the normal value, and it turned out fine. Similar to ABS, the ABS filament ends up a bit too sticky on the printer bed, and I was not able to remove it. I guess this PEI build plate expand a bit more compared to other one in a higher temperature, which is interesting. However, like many other printers, Neptune 3 is not perfect. There are some users report that old phone cable style screen connector are sometimes having connection problems, which in my unit, it seems to a bit loose too, but so far, I don't encounter this issue yet. I also don't suggest to move the touchscreen off its holder if there's no necessary, which it will increase the chance of connection problems. The little SD card is hard to insert. As you can see on my unit, the card slot is not perfectly matching to the SD card slot. I wish it will come with the SD card instead of micro SD card, which it will not adding too much cost to manufacturing them. But when I check the board layout, there are not much space for a larger size SD card. But with $220, I will suck it up. The pre-assembled part are very nice, but make sure you recheck all the fasteners when you assemble the printer. My printer bed was coming loose after around 20 plus test print. So that's something that to keep in mind. Also make sure you redo the auto bed leveling every time you make an adjustment on the bed mounting screws. The dual 4010 part cooling fans work nicely for the most print. Unless you are doing something like crazy overhand like I did on the test print, the cooling air come out from the dot and separate in a very wide area. There is a room for upgrade design for redirect the cooling air. The ribbon cable will slightly hit the gantry when you're homing the x-axis, which creality spider extruder also have this problem. I don't think this will cause any damage, but it just makes me uncomfortable. The touchscreen work nicely, but sometimes the commonly used UI like disable stepper and LED light are hidden within other features with a small text. It would be nicely if they reorientate those commonly used ones on top of the menu. Also, there is no physical switch to turn on and off the LED light. You have to control on the touchscreen, since LED lights are hidden under the top block. The light will be blocked by the gantry and extruder. The print area will undershadow, but Again, with $230, it's already nicely over LED light with this printer. The extruder comes with titanium heat break, but it is not full metal. There's still TPFE tubing insert. It will hold out with no issue if you are normally printing with PLA, PETG, TPU. But if you are printing a lot of high temperature filament like carbon fiber, ABS, or polycarbonate, you may want to upgrade to full metal heat break to prevent TPFE tubing melting. The full metal heat break costs around $5 each, so it should be cheap and simple upgrade. Which all those cons I won't consider as a deal breaker for me, but it's up to you. Back to money again, Elegoo offers solid hardware value and almost $100 off its price compared to its competitor. The biggest problem for it right now is it's not available on its site. It is out of stock most of the time for both its official site and Amazon. Despite its still fresh release and international transportation issue right now, at the same time, the availability of some repair part might be something you need to concern. At this point, there's not much out there. But I could see this printer will outsell in near future. There will be more video about this printer, like convert to a Klipper and upgrade. Stay tuned. Thank you for watching. I'll see you next time. I'm telling you, it's handy when you go bathroom at night.